Hello, welcome back. This video is a follow-up to the last one, I'm gonna assume that everything in there. If you need to go back and look at that one, no big deal. But we are going to try and get through this one quickly. You want to have VS Code installed. That's what I've been using. In this VS Codium, it's the same, just without the Microsoft spyware. And then you're going to want to download the demo that I've got on GitLab. I've just downloaded it as a zip file. You can use Git, and we'll probably want to do something that makes a little bit more sense when we're actually developing, so that we can use Git a little bit faster and easier. But once you've got those two folders, the Buzz and GT demo, you might also want to take a look at the README. But we're also going to navigate to the Redox recipes folder in WSL here. And then I do have one little tip. If you right click on a folder and pin it to start, and then you can use the start menu to just search for it directly like that, which is pretty nice. But we're going to start just by copying over these two folders, and then inside of each of these are our actual like Rust packages, and we're just going to want to turn them into Redox packages by making this source folder and dragging what we need into there. Actually, let me grab. You can use the same recipe.toml that we made for the Mandel. It's just the single or two lines, I guess. And we will turn both of these folders into the right organization for the Redox package. And now that that's done, we also want to make sure that these daemons, Buzz and GT demo, both start at boot by adding them to the initial initfs, and that is going to be in core initfs and then init.rc. And you can see I've already added them here. They just need to go after this line, so at the end of the file. And then you can save it and close it. Now we are going to go ahead and make sure that VS Code is good to go. You're going to want to get the WSL remote extension. I don't know if you actually have to install this in normal VS Code, but you can just search WSL, and there's a blue one that comes up by Microsoft. Also recommend getting the Rust extension pack. I'm not sure if it's the same one that's available on normal VS Code. It doesn't say it's installed here, but it is installed in WSL, which we'll see in just a second. Once you have the WSL remote installed, you'll see something like this, or at the bottom, this open a remote window. And so we can just connect to WSL that way, and we'll have to give it a second. And now you can see the Rust extensions from WSL are loaded. And now that we are in WSL, we can actually open the folder, and that again, or folders, sorry. Redox cookbook, recipes, Buzz, and then we will open another window, just this way, and file, no, sorry, open folder, Redox, cookbook, recipes, GT demo. And that way we can quickly open up and look at all of our necessary code And then if you wanted to look at the cargo or recipe tomls, you could just go further down and open the source with this stuff. But that way we can just have two windows open with both of the programs for the demo at the same time. Now you do not want to build Redox inside of VS Code. Instead, we are going to do that from a separate command line window. And we're going to go back to our Redox folder inside WSL here. And first, we're going to want to rebuild the file, the initfs. This will make those changes to the initrc file, so that both of our demo programs here will start on boot. And these R dot and CR, these are like the individual recipes. And so now that we have that rebuilt, we can make our two program recipes by using the R dot and then name of the program or recipe. And then we also want to use the desktop configuration, and you're also going to want to make sure that your Redox desktop config x86 has GTDemo and Buzz in there like this, just like we put the Mandel one in here. Although the Mandel one probably should go in the x86 one specifically. But these ones absolutely need to go in the x86 one. And then make r.gtdemo, r.buzz, desktop, and then live for the ISO file. And we should be able to just let her rip. This shouldn't take nearly as long as building the whole operating system. I'm kind of hoping that this will actually just go in. I'll be able to let this run in real time. I might just speed it up a little bit and you can watch the clock. Okay, and now that our ISO is built, we can open VirtualBox and start our Redox VM. And of course the mouse pointer is going to bug out here. I also am not really sure what it's doing there, but we will go ahead and bring our mouse into the VM here. And from here we can run the demo by typing dd input file scheme buzz of equals scheme gt demo count. Oh, didn't need that space. And so this will run, it'll run our demo, and to see the log from GTDemo, we can cat for concatenate scheme sys log, and this will print out our log file. And we can see that we have printed buzz from the buzz daemon, and we have read a random character from the random daemon. Yeah, and I guess I could take a quick look at the code here and just, I guess, kind of walk through. Actually, let me do well, you can see the buzz string is stored here, and then you will not be able to find any buzz string in this file. Once we have once we're in the loop here, it's just going to read a sequence of characters from the buzz daemon, and you can read the comments for a little bit more detail here. And this says, okay, only when it's copied over and not just on any request. Then we're going to take the data that we have, and we're going to act on that. And in this case, if it's an exclamation point, we're going to open the RAN daemon, and this shows up differently on my machine. This will print the rand variable here, and then there is a we can coin flip, and we can open the buzz daemon and change what is inside of the buzz daemon as well by running this a couple more times and hoping that we get lucky, basically. And yep, we can see that we rolled. Oh, sorry, we rolled above a 127 the first time. So then GTDE gets written to the daemon. The reason that the whole thing doesn't get copied over is because the buzz daemon will see its type is limited to a size of 5, and there is we don't have to worry about like overflow or going over, because we only iterate over the entries we have in the buzz scheme. And of course, I do recommend reading through the code here to actually see what all is going on. But that's it. Thank you, and let me know if you have any questions.